Hello everyone. Today I will discuss few questions related to exercise 1A, concise physics. Okay. So the first question is, what do you understand by the clockwise and anti-clockwise moment of force? So the answer will be, if the effect on the body is to turn anti-clockwise, the moment of force is called anti-clockwise moment. And anti-clockwise moment is taken as positive. Anti-clockwise moment is taken as positive. While if the effect on the body is to turn it clockwise, moment of force is called clockwise moment, which is taken as negative. Question number 8, exercise 1A, concise physics. State one way to reduce the moment of a given force about a given axis of rotation. So how can you reduce the moment of a given force about a given axis of rotation? So we know moment of force depends upon the perpendicular distance. It depends upon the perpendicular distance of line of action of force from the axis of rotation. So the moment of force can be decreased or reduced by decreasing the perpendicular distance. So we can decrease the perpendicular distance. If we can decrease the perpendicular distance from the axis of rotation or from the pivoted point, we can reduce the moment of force. In a similar way, in question number 9, state one way to obtain a greater moment of force. So we have to increase the perpendicular distance of line of action of force from the axis of rotation. We have to increase the perpendicular distance. Okay. Now question number 14. A jack screw is provided with a long arm. So why the jack screw is provided with a long arm? Actually, the long arm of a jack screw is used to lift a heavy load, like a vehicle, with the help to apply less effort, which is required to rotate it to raise or lower the jack. Hence, the jack screw has longer arm. So the jack screw has longer arm as because if the perpendicular distance is more, okay, so we can obtain greater turning effect by applying less force. This is the actual reason. Now next question number 16. In question number 16, one diagram is given like this. This is the point O. And this way the diagram is given. Okay. The adjacent diagram shows a heavy roller. The heavy roller with its axle at O. So here the axle is given, which is to be raised on the pavement XY. So this roller has to be raised on the pavement XY. If there is a friction between the roller and the pavement, so by an arrow on the diagram, the point of application and the direction of the force to be applied. So the force should be applied in this direction so that it can be lifted upwards. So the arrow will be like this. This is the force. Okay. Now question number 17. A body is acted upon by two forces, each of magnitude F. So two forces are there, each of magnitude F, but in opposite direction. Okay. So one force is like this and another is like this. So the net force will get cancelled. So resultant force will be F minus F. Or you can write like this, F plus minus F. So 0. If the two forces act on two different points on the body at a separation R, then moment of force will be given like this: moment of force equals to F cross R. Next, question number 20, question number 22. What do you understand by the term equilibrium? What do you understand by the term equilibrium? When a number of forces, acting on a body produce no change in its state of rest or of linear motion, linear or rotational motion, then the body is said to be in equilibrium. Then the body is said to be in equilibrium. Okay. Now question number 25. State the principle of moments. Actually, according to the principle of moments, we know that algebraic sum of moments about the axis of rotation of all the forces acting on a body is zero. Okay, that is the sum of anti-clockwise movement will get balanced by the net sum of the clockwise movement. A beam balance, name one device based on it. So we can say that the device which is based on the principle of moments is the beam balance. Okay. Now let us discuss the numericals of this chapter, chapter number 1, exercise 1A. The first question or the first numerical, question number 1. The moment of force of 10 Newton about a fixed axis O is 5 Newton meter. So the moment of force equals to 10 Newton. Sorry, moment of force. We have to find the moment of force. Force is given as 10 Newton. And moment of force is given as 5 Newton meter. So what will be the perpendicular distance? So we know moment of force equals to force multiplied by perpendicular distance. So 5 Newton meter equals to 10 into perpendicular distance. So the answer will be 5 by 10, that is 0.5 meter. Now next, question number 4. A diagram is given like this. This is F2, 3 Newton, F1, 5 Newton. This is the point O. AB is the rod and the distance is 2 meter and this distance is 4 meter. So the first question is the moment of force F1 about O. So what will be the moment of force? F1 into this distance OA. So 5 into 2, that is 10 Newton meter. And this will produce an anti-clockwise moment. So it is anti-clockwise. Okay, that is plus 10 Newton meter. Now, number 2, moment of force about F2. So F2 will produce clockwise moment. So what will be the value of the moment of force? Minus 3 into 4, that is minus 12 Newton meter. So total moment, question number 3, total moment equals to plus 10 Newton meter plus minus 12 Newton meter, that is minus 2 Newton meter. So you can write this as 2 Newton meter in bracket clockwise. Minus sign denotes clockwise movement. Okay. Next, question number 8. A uniform meter rule is pivoted at its midpoint. So this is an uniform meter rule. This is 0 centimeter, 100 centimeter. It is pivoted at its midpoint, that is 50 centimeter mark. Okay. A weight of 50 gram force is suspended at one end of it. So weight of 50 gram force is suspended at one end of it. So if we suspend the weight here, it will produce a clockwise movement. So what will be the value of the clockwise movement? Clockwise movement equals to 50 into 100 minus 50, because this is the distance. You can say this is W1, this is L1. So 50 into 50, that is 2500 gram force centimeter. Okay. Now we have to balance it. So what will be the anti-clockwise movement? Where will the weight of 100 gram force should be suspended? So let the weight of 100 gram force be suspended at a distance x on the other end. So anti-clockwise movement will be anti-clockwise equals to 100 into x. So 100x equals to 2500. So x equals to 25 centimeter from the other end. So weight of 100 gram force should be suspended at a distance 25 centimeter. Should be suspended at a distance 25 centimeter from the other end to keep the rule horizontal. So we can say the 100 gram force should be suspended here to produce the anti-clockwise movement. Okay. Now next, question number 9. A uniform meter rule balances horizontally on a knife edge placed at the 58 centimeter mark. So this is the uniform meter rule. This is the 50 centimeter mark, 0, 100. So we know that uniform meter rule has uniform distribution of mass. So the weight will act on the CG, that is in the center of the gravity. So it is placed or balanced at the 58 centimeter mark. So suppose this is the 58 centimeter mark. So what will be the distance? L1. This one will be L1. And if we suspend 20 gram force here, because this will produce an anti-clockwise, so to balance it, we have to place the 20 gram force here. So what will be the distance? L2. This will be the L2. So W1 L1 equals to W2 L2. So what will be the value of W1? mg into L1. L1 is 58 minus 50 equals to W2 20 into L2. L2 is 100 minus 58. So mg into 8 equals to 20 into 42. So what will be the value of mg? 4 2s are 8, 4 5s are 221. So 105 gram force. Okay. So what will be the mass? 105 gram. If the weight is 105 gram force, the mass will be 105 gram. Next, question number 10. A diagram is given below. A uniform bar supported at the middle O. A weight of 40 gram force is placed at a distance 40 centimeter left of the point O. So the diagram is given like this. Here the point O, fulcrum is given like this. Here the 40 gram force is given at a distance 40 centimeter. Okay. So what will be the anti-clockwise movement? 40 into 40 minus 0. This is the anti-clockwise. It will be balanced by the clockwise movement. So clockwise movement 80 gram force. W2 is given as 80 gram force. So 80 into x. So find the value of x. X is 1600 by 80. That is 20 centimeter right of O. Right of O. This is the point O. So here it will be the distance here. Now next question number 11. In question number 11, a figure shows uniform meter rule placed on a fulcrum at its midpoint. So the question number 11. This is the point O. Here at the 10 centimeter mark, a 40 gram force is placed. Here at the 90 centimeter mark, a 20 gram force is placed. And this is the 100 centimeter mark, and this is the 0 centimeter mark. Okay. So now, first the question is the meter rule in equilibrium? So suppose to find the condition for equilibrium, what we have to find, that is the total clockwise movement or total anti-clockwise movement gets balanced by each other. Okay, so net anti-clockwise movement equals to 40 into this distance. What will be the distance? This is the 50 centimeter mark, this is the 10. So 50 minus 10. Okay, so 40 into 40, that is 1600 gram per centimeter. Now what will be the clockwise movement? Clockwise, this is the anti-clockwise movement and this is the clockwise. So clockwise movement equals to weight is 20 multiplied by this distance. What is the distance? 90 minus 50. Okay, so equals to 20 into 40, that is 800 gram per centimeter. So the net anti-clockwise movement is not equals to the net clockwise movement. So the meter rule is not in equilibrium. Okay, if both have the same result, then we can say the meter rule is in equilibrium. But here the anti-clockwise movement and clockwise movement differs. So the meter rule is not in equilibrium. Now question number 2. 11 subpart 2. If not, how will the rule turn? If the condition of equilibrium is not satisfied, how would the rule turn? So here the value of the anti-clockwise moment is 1600. Here the value of clockwise is 800. So the value of anti-clockwise moment is greater than the clockwise moment. So the rule will turn anti-clockwise. So the rule will turn anti-clockwise. Now question number 3. Question number 3. How can the rule be brought in equilibrium by an additional weight of 40 gram force? We have already found that the anti-clockwise moment is 1600, which is greater than the clockwise moment 800. So we have to place the extra weight of 40 gram force in the right side, that is in the clockwise direction. But we have to find the distance where the 40 gram force should be placed. So to balance this moment, we have to place the clockwise. We have to place the weight in the clockwise direction, clockwise, to produce clockwise moment. So 40 into x, that is 1600 equals to 800 plus 40x. So 40x equals to 800. So x equals to 20 centimeter on the other side, on the other side. Okay. So the rule can be brought in equilibrium by placing the additional weight of 40 gram force at a distance of 20 centimeter on the other side. That is, the middle point is 50 plus 20, that is 70 centimeter mark. 70 centimeter mark. Okay. The middle point is 50. From there, additional 20. So the 70 centimeter mark. So you have to place the additional weight of 40 gram force at the 70 centimeter mark. Okay. Next question. Question number 12. When a boy weighing 20 kg sits at one end of a 4-meter long seesaw, so this is the 4-meter long seesaw, 2 to 4, it gets depressed at ends. Boy weighing 20 kg sits at one end. Okay. It gets depressed at its end. How can it be brought into horizontal position by a man weighing 40 kg? So this will produce anti-clockwise movement. So 20 into 2 equals to 40 kg meter. Okay. So we have to place the additional weight here, 40 kilogram force in this direction at a distance x from the middle. So now 40x will balance this 40. So x equals to 1 meter. So it can be brought to horizontal position if a man sits at a distance 1 meter from the center on the opposite side of the boy. Here the boy is sitting. So man has to sit here at a distance of 1 meter from the center here. Now let us discuss the question number 15. Okay. Question number 15. A uniform meter rule of weight 10 gram force. So weight of the uniform meter rule is 10 gram force. Okay. It is pivoted at the 0 mark. So it is pivoted at the 0 centimeter mark. This is 100 centimeter and this is 0. Okay. So net weight will act here. This uniform meter rule. The net weight will act at the 50 centimeter mark at the center of gravity. This is W1 equals to mg. Okay. Now let us calculate the anti-clockwise movement. So what will be the anti-clockwise movement? A uniform meter rule of weight 10 gram force. Oh, sorry. This is given as 10 gram force. Weight is given as 10 gram force. So now W1 L1, that is the anti-clockwise moment. The value will be 10 gram force multiplied by, this is the distance from the pivoted point, 50 minus 0. That is 500 gram force centimeter is the anti-clockwise moment. So what moment depresses the rule? 500 gram force centimeter. Now, how can it be made horizontal by applying least force? So it can be made horizontal if it is balanced by a clockwise movement. So now let the next weight be W2. Okay. So we have to find W2. So 500 will be balanced by some clockwise movement W2, that is the weight, and the distance is 100 centimeter because this is the pivot point and this end is total 100 centimeter. So the L2 will be 100 centimeter. So W2 L2. So 500 equals to W2 into 100. It is W2 equals to 5 gram force. এটা আমরা কেন এই টোটাল ডিসটেন্সটা নিলাম? অ্যাকচুয়ালি আমাদের 0 সেন্টিমিটারে যখন পাইভট করা হয়েছে তখন আমাদের প্রথম যে ব্যালেন্স পয়েন্টটার থেকে আমাদের কি হচ্ছে, এই ডিসটেন্সটা 50, এটা L1 বেরোলো। আর সেকেন্ড আমরা টোটালটা যখন নিচ্ছি তখন কিন্তু পাইভট পয়েন্ট থেকে ক্যালকুলেট করব, ব্যালেন্স পয়েন্ট থেকে। ব্যালেন্স পয়েন্ট থেকে এই ডিসটেন্সটা কত আছে? 100। নেক্সট কেসে সেই জন্য 100 নিয়েছি। ওকে। তাহলে আমাদের 5 গ্রাম ফোর্সটা 100 সেন্টিমিটার মার্কে আমরা প্লেস করব। Next, question number 17. A uniform meter rule of mass 100 gram. This is the uniform meter rule of mass 100 gram. So mass of the rule is 100 gram. So weight will be 100 gram force. Mass is 100 grams, so weight will be 100 gram force. Is balanced on the fulcrum at 40 centimeter. So it is balanced at the, this is the 50 centimeter. So this will be 40 centimeter. It is balanced at 40 centimeter mark. Okay. By suspending an unknown mass m at the 20 centimeter. Here, this is the 20 centimeter and mass m is suspended. Okay. Find the value of m. So first we have to find the clockwise movement. Okay. So what will be the clockwise movement? If we calculate the anti-clockwise movement and the clockwise movement, the value of anti-clockwise will be m into distance. This is the pivoted point, so the distance will be 40 minus 20, like this. And what will be the value of clockwise movement? Clockwise movement, 100 gram is the weight of the rule multiplied by, so this is the weight of the rule multiplied by g. Why we have multiplied here by g? Because m into g is the weight. Actual formula is W1 L1. So W1 is m into g and L1 is 40 minus 20. Here also W2. W2 is m into g into 50 minus 40. Because this is the distance from the balance point. Here the weight is suspended W2. So W2 100 into g into 50 minus 40. So the value of m will come out as 50 gram. Okay. Now if the mass m is moved to the 10 centimeter mark, so mass m is moved to the 10 centimeter mark. Okay. Then to which side the rule will tilt? So if the mass is moved to the 10 centimeter mark, the rule will tilt anti-clockwise. How? If the mass is moved to the 10 centimeter mark, the anti-clockwise moment will be anti-clockwise. Anti-clockwise moment will be 50 into g into 40 minus 10. Now this is the distance is 40 minus 10. 40 minus 10. So 1500 gram force centimeter is the moment, and clockwise moment equals to 100 gram 100 into g, sorry, 100 into g into 50 minus 40, because this distance is same, so it is 1000 gram force centimeter. Now the resultant moment, what will be the resultant moment? So resultant moment, first, this is the anti-clockwise 1 plus 1500 plus this is clockwise, that is minus 1000. So 500 gram force centimeter positive, that is anti-clockwise. So the resultant moment 500 gram force centimeter is in the anti-clockwise direction. Okay. Now next, question number 4, 17 subpart 4. How can it be balanced by another mass of 50 gram? So we have already seen that the value of clockwise movement is 1000 gram per centimeter and anti-clockwise is 1500 gram per centimeter. So the value of anti-clockwise movement is more. So extra weight has to be placed in this side. So 1500 equals to 1000 plus what is the extra weight given? 50 gram mass. 50 into x. Okay. So 500 equals to 50x or x equals to 10. That is 10 centimeter. So it can be balanced by suspending the mass of 50 gram at the which centimeter mark? At a distance of 10 centimeter from the 40. Actually, the 40 centimeter is the pivoted point. So we have to place it here. That is 40 plus 10. That is on the 50 centimeter mark. We have to place the weight at the 50 centimeter mark. The other questions has been already discussed in the class. But for more information, subscribe my channel. Thank you.